welcome to the technical track. So our first speaker is Francesco Minetti. Francesco is a former chemist turned cybersecurity specialist, and his passion is hunting bugs in Android and web application. So today he will show us a methodology for the discovery of web cache deception vulnerability. So Francesco, the stage is yours.
Hi everyone, I'm Francesco Minetti. I'm very happy to be here. Thank you for being here. Basically, I work as a cyber security specialist in a little company, in a startup. In my free time, I do bug bounty because, you know, second income is always great. We all need money. I'm not rich. And also for sharp my skill, so that's a good way. You can find me on the HackerOne platform with the handle F_M. I have also a GitHub repository with a tool related to this talk. So let's start. This is a work based on my thesis degree and years of bug hunting and hunt for web cache deception. I spent more or less 3 months to do this. My goal was digging into the web cache deception world, discover new edge cases, exotic cases, and also I discovered some interesting chain. I've had some result, like I've done a paper with my professor Marco Anisetti and PhD Filippo Berto. I wrote a tool for finding web cache deception vulnerabilities, and as I said before, I found new cases. So let's start. This is the structure of the talk. First, I will introduce you to the web cache deception vulnerabilities and the recent research work, the available tools, some exotic case that I found in bug bounties that nobody talk about. Of course, the tool I wrote, the scanning results of the tool, some web cache deception chain, and then I will proceed with conclusion. So first of all, what's web caching? Web caching was introduced for avoiding useless traffic, useless HTTP traffic. In modern days, 90% of web applications have some caching technologies or multiple caching technologies. These help them to avoid useless traffic. Here is an example, a classic example. In step 1, a client sends a request to some endpoint, let's say endpoint PHP. The intermediary node, the web cache node, forward the request to the origin server. Then the origin server responds to the intermediary node, and the intermediary node here, based on some cache configuration, can decide to save the resource in cache, then return it to the client. And the next time a client on the web requests the same resource, the resource will be served by the intermediary node, so they can avoid useless traffic between the intermediary node and the origin server, and improve, of course, performance. What's behind the cache configuration? Cache configuration are based on what it's called cache keys. Cache keys can be a lot of things, like the path string, the query string parameters, cookies, headers, and a lot of stuff. You can configure your web cache to store some resources and no other, and that's it. So what can go wrong here? A lot of things can go wrong. This is the basic schema diagram of web cache deception attack. In this example, an attacker send a link to the victim. The link contains an initial part with an existing resource like account.php. Then it merged the real path with a non-existent resource, like here /nonexistent.js. And one important thing is that this resource that not exist is a static resource, so technically cacheable. When the victim click the malicious link, a GET request with session cookie will be sent as a normal top level navigation GET request. The request reach the intermediary node that forward the request to the origin server. The origin server, for some reason, there are a lot of reasons, responds with the resource requested with sensitive content inside the body of the HTTP response. Then the cache save by seeing the static extension, think that this resource is static, then save it locally, and return the resource to the client. Then an attacker can simply request the same resource with the same path, the same cache keys, and of course obtain the sensitive content. This is the basic attack. So let's dig into the web cache deception history, because it all started in 2017 with Omer Gil. This guy discovered this vulnerability. This was the beginning. He described the attack on multiple caching technologies like CDN, reverse proxies, etc. Because this the intermediary node can be, for a classic example is a CDN node, a content distribution network node, but it can be also a reverse proxy like Nginx. And sometimes, if I took an example, for example, the WP cache plugin, there is no intermediary node. It is the origin server that cache some resources to serve it quickly. So this was the beginning. Then in 2020, a group of University of Trento in Italy with other people in the IT security community bring to the public this paper called Cache and Confuse Web Cache Deception in the Wild, where basically they discover that some interesting variation. They use the limiters. So, for example, some origin web server, if they receive a semicolon character, they think that the path is ended here, and they didn't take in consideration the part that came after the limiter. In this case, for example, the encoded semicolon character %3b, or same thing with encoded question mark character. Also, carriage return line feed character works well, and of course even the encoded fragmented identifier, the encoded hash character. So basically, web cache deception are a vulnerability that arises from a discrepancy in how the origin server parse the request path string, and how the intermediary node is configured to cache resources based on the path and cache keys. Then later in 2022, the same group bring out another paper called Web Cache Deception Escalates. Basically, they discovered that also double encoded delimiters work well for cache deception in some cases. And they didn't stop there, but they do, of course, with this can be done with all the special character, the delimiters character used previously. So double encoded semicolon, double encoded question mark, double encoded hash character, etc. They also made a tool. This tool was made for a large scale analysis. Basically, this tool work by checking the response header related to caching. And if this tool see that a resource is cacheable just by adding a web cache deception payload, it trigger an alert in the console, so the user of the tool can verify that this is a real web cache deception or not. This tool was tested on a huge list of domains, and they obtained great results. Of course, they check manually every positive alert of the tool. Because, of course, if you base your web cache deception, your tool for finding web cache deception only for only by checking the response header related to caching, you can have a lot of false positive. So they check manually all the results. Then in 2024, the Porzwigger research team made another paper that was about web cache poisoning and web cache deception. In this paper, the web cache deception part is about path traversal sequences. So imagine you have configured your cache to cache every resource that start with a specific part, like /static/ and combined with a 200 response. What's going to go wrong here? Well, some origin server can, for example, in this first example, you can see this payload /./account PHP. So what's happened when the cache server received the request? It see the static string, so he think it's like, let's say, like a JS, a static resource, because it's configured for storing that. It forward the request to the origin server. What the origin server do is see the .. semicolon / the path traversal sequences, and interpret this as account PHP. So it responds with a 200 response. So for the web cache perspective, this is cacheable because it have a static a path start with static, the static word, and have 200 response. So it can cache. So it cache sensitive information. In this case, account PHP. The same thing basically can be done with other path traversal sequences like classic .. encoded, in this case. Encoded because if you click a link with .. in the path, browser automatically normalize the path. So for perpetrate this attack, you need to encode the path traversal sequence. So the current automation cover some cases, but it's made is made for large scale analysis. It uses headers, as I said previously. What I mean by header, every web cache has some header that they added in the response to indicate whether a resource has been retrieved it was retrieved in the cache or by the origin server. For example, a classic header is the Cloudflare X cache header that can have a lot of value, like miss, indicating that the web cache has forwarded the request to the origin server, or hit, indicating that the resource was stored in the cache and served directly by the web cache server. Or expired, indicating that the resource requested by the client was expired in the cache, because resources in the web cache have a time to live, or have not an infinite live. So it can be 600 seconds, but at some point the resource in the cache will expire. What's the problem with the existing tool? That it misses a lot of cases, edge cases and exotic cases. I will show you soon what I mean by exotic cases and edge cases. Basically, in my bug bounty hunting career on HackerOne, I found a lot of web cache deception, and I was lucky enough to find some edge cases that no one talked about. So let's start. One of the easiest edge case is that the previously tool don't detect is where you have a web cache deception, but you don't have cache-related headers. So if you see here the response, it was a 404 response containing some personal information that I will show you later, but there is no cache-related header. No header. So here, as an example, this is a victim request, and here is the attacker request without cookie, without authentication, and in this case, I was able to steal, for example, phone number, username, email, and other personal identifiable information (PII) of the victim user in one click. Another edge case, this is pretty rare, but it happened. Sometimes developer configure the cache for save every resource, for example, every HTML resource, but they forgot that in the HTML resource there can be some personal information, cookies, session, token, etc. So it is this is one of the biggest bounty I have heard. This is it was a program related to NFT, so they were paying very well. This is the cache deception I found. You can see there is in this case, of course, you cache hold, so there is no payload. I was just querying the home page. And you added a query string as a cache buster. So why that? Because I have to do a proof of concept, so I had to insert some identifier that if the victim click, he only click that. It was for, let's say, I need that query string for create a unique cache keys. This is the request of the victim, the GET request, where you can see all the session, cookies, etc. And here is the attacker response, then the attacker request. Same cache keys. There was a JSON web token of the victim stored in the HTML. With that JSON web token, I was able to completely take over the victim account. This was paid to $20,000, so it was my biggest bounty. And you know, I call it the easy one because I didn't put a payload there. You know, can you imagine you are hunting for bugs, you wake up in the morning, just see the source of the home page, you see that there is a JWT, but it's not your JWT, so you win, you earn $20,000 for checking the source code of a web application. That's also this had a critical impact. Why? Because yes, I could craft a link to send to the victim, but if the first user of that request a specific HTML page was authenticated, then an attacker can just query the same page and retrieve the user's JSON web token, so without user interaction, no click required. It's rare, but believe me, it happened. Sorry, believe me, it happens sometimes. So another edge case I found was an edge case with cookie required. I was aware that, for example, application that uses, for example, the Cloudflare reCAPTCHA set a special cookie in the user's browser to indicate where or not the user have completed the reCAPTCHA. So for retrieving, in these cases, I was aware of that. For retrieving the cached content, the attacker need his own Cloudflare cookie. What I wasn't aware of, was, but basically, I was hunting on HackerOne in this program that have a lot of online shops, e-commerce, based on Magento e-commerce. I found a very strange web cache deception, and the HackerOne triager assigned me this CV. I tried to check this CV, but the advisory was a little bit confusing. But anyway, I believed him, and effectively, I discovered that this bug was a default product behavior, and so this version of Magento e-commerce was vulnerable by default, and that was an interesting one. What I mean by cookie required. I'll show you an example. This is a classic web cache deception victim request. And then here is the attacker request. As you can see, there is a xMagento very cookie with a value that can seem random, but in reality it's equal for all the users, so an attacker can easily guess. This cookie is considered as a cache key. So if you send a classic web cache deception request to retrieve a cached resource without cookies, the web server doesn't respond with the cache resource. You need this cookie. What I was able to do with this type of web cache deception, basically steal the CSRF token of the victim user. Of course, I didn't stop it here, but I perpetrated a web cache deception plus cross-site request forgery attack. I used these simple proof of concept. Basically, what this proof of concept does is, first, it opens a new tab in the victim browser with the web cache deception payload. Then wait for 50 seconds. Then it does a call to the attacker server. The attacker server, it's not here, but what the attacker server do? The attacker server, when he receive the request, he get the same URL with the Magento vary cookie, retrieve the CSRF token, and response to the user with the CSRF token. So at this point, it just with JavaScript, I was able to insert the CSRF token, submit a form, and perpetrate a CSRF attack that change the user profile information. This can be done only if the same site cookies attribute isn't set or is set to none. If the same site cookie attribute is set to lax or strict, this won't work. You can steal the CSRF token, but it's useless. Then another case I found that isn't covered by the current tool is when cached resources are modified dynamically by the cache server. It's quite rare, but not so rare. An example of this is web application that uses the Cloudflare email obfuscation. So what's Cloudflare email obfuscation? Cloudflare email obfuscation is a methodology to hide site-related email and avoid web scraping, basically, that collect these emails. But what it does? Well, when a resource is cached, it changes a little bit the HTML to obfuscate an email in the HTML. So every time you hit the same resource in the cache, the content of the body will not be equal. It's different. So a lot of tools made the assumption that cache resources are the same, have the same body. But that's not true sometimes, like here with the Cloudflare email obfuscation, or sometimes with cache timestamp in the HTML, as in the HTML content comment. So after that, I decided to make a tool that automate the process of finding web cache deception. I made it public yesterday. So here is a tool. I call it, without too much fantasy, WCD probe, web cache deception probe. He have the aim of finding all the possible cases of web cache deception. It uses response body content parsing to detect web cache deception. Of course, it checks for the previously shown cases, and it requires authentication because, you know, web cache deception vulnerability requires authentication, and while the talk I mentioned previously work without authentication, this tool work only with authentication to correctly see if there is or not a web cache deception vulnerability. So how it's composed? It's written in Java and Maven, using Maven for an easy build, you know, Maven clean install. It's compiled. It uses Selenium for web crawling. And he have an extension, a browser extension that help you to send cookie to the program and start autonomously the scan. So you can just log in into your browser, load in the extension, indicating the domain you want to scan. The extension will send the cookie directly to the program, and you can start the scan very easily. Also, you can paste the cookie, copy and paste the cookies, and run the tool via command line interface. This is how it works. So there is an initial phase where you log in. You start the process by running the tool from the extension and or the command line. So if you think about web cache deception, there is a limited attack surface. The attack surface is basically the whole HTML links. So if you collect all the HTML links, you have the whole attack surface on your own. So it crawl using an headless browser, the web application, collect the whole link. Then for every link, it try a web cache deception attack. It try to extract marker. What I mean by marker are strings that you can insert in a configuration file of this tool. Typically, the username, your email, your phone number, so the tool can check if they are cached. Also, it check if there are a cookie in the cached response, and it check also if there are CSRF token in the cached response. And then it print the output in the console. So here a little screen of the tool, the extension. As you can see, you can use it in various ways. For testing the automation, I selected 100 domains with sensitive info in the HTML. So no pure single-page web application. I needed the domain where resources have personal info inside. I tested this domain and I analyzed the results found. So 13 over 100 websites were vulnerable. These are the impact I found. So the green one was useless. So for example, the attacker can retrieve only the username. You can do nothing with the username. It's garbage. Sometimes I could take over an account, perpetrate a CSRF attack, or PII theft. Here are the technology that I found vulnerable. You can see reverse proxy, CDN, local Magento cache. Here is a typo, sorry. And these the response codes of the cached resource. So it's not always a 200. It can be 410 gone, 404 not found. A lot of codes. So what's the pro of my tool? It can cover a lot of web cache deception cases, including the cases I showed you before. It is not prone to false positive because it checks if there is something personal in the cache resource. If not, it don't print that you found a web cache deception. Of course, there are false positive, but it's lesser prone than other tool. You can configure also this tool. You can configure the depth of the recursion of the crawling recursion phase. You can configure the max limit of the link collectible in the crawling phase. And then there is a payload configuration file where you can put the payload you want to test. Cons, it requires authentication to work well. It can take some amount of time to test a domain because it goes slow for avoiding rate limit issues and stuff like that. And of course, it has to parse all the content for every link, for every payload. A cons, of course, it's that it can work in presence of anti-bot software like CAPTCHA or JavaScript that check the Windows WebDriver property. So in these cases, as now, it can work. So there is a last part. I ask myself, how can I let the victim send a GET request without a victim click? If you think about web cache deception, the requisites are unique. Because this type of vulnerability only need a GET request to work. If you think about, for example, reflected XSS, it does not only require the GET request, but it required also that browser interpret the reflected payload in the response. This is not the case for web cache deception. How I can do this? Well, some webmail client do this when opening an email with external media inside. Or some blog sites can have images that can have an arbitrary path, and so can send a request without a victim click. What I tried is first is that the basic idea is the attacker send an email with in the body two images, one pointing to his server and the other one that with the web cache deception payload. The victim open the email without clicking any link. Two requests will be started, initiated. One to trigger the web cache deception, one to the attacker server, indicating that the web cache deception has started, so the attacker server can retrieve the resource content and steal the cached content. I tried this with a one-click account takeover web cache deception I found on HackerOne, a certified, one of the most used certified email web client in Italy. I can't say because, of course, there is NDA. So here is the initial phase. The attacker send the payload request, the payload email. The victim received the email. You can see it trigger a GET request to the web cache with the web cache deception payload. So the attacker can retrieve in this case, the session cookie of the victim and steal his account. So there is some requisites for this attack. My work was it was done in 2023. Unfortunately, there was a delay between publish the paper of this talk and the date I've done this work. So what's the chain requisite? The browser doesn't have to, the browser doesn't support the state partitioned cookies. It was the case of Chrome until late 2023. The webmail client must filter body media elements, or an attacker must have a way to bypass the filtering. And there was historically a huge number of these bypasses, even for Gmail, for example. The session cookie same site attribute must be set to none. Otherwise, since this is not a top-level navigation request, session cookies will not be sent. This chain worked with the above condition until late 2023, but what I found interesting is that before the implementation of same site attribute in cookies, before the implementation of state partitioned cookies, session storage, etc., there was a time where web cache deception was a public known vulnerability, and this attack worked with every email client that doesn't filter the email content. So I'm sure 100% that a smart bad guy around the world during these years have exploited that, of course, because it's too easy, too easy. What we can do nowadays, we can do a similar attack, but based on a different technology. For example, if you think about a blog post with comments where you can insert images with the same domain and an arbitrary path, you can you can insert in the comment section web cache deception payload. Then every time a victim see this page, it triggers a web cache deception, and the attacker can probe this path to see if someone have been tricked. So even there, no user interaction, zero click. Conclusion, so some web cache deception has been discovered and investigated by myself. A tool for automate the process has been written. Some bugs has been found in public-private bounty program. Of course, I earn some money. As I said previously, I came from a poor family, so I need money. Some chain has been discovered, and maybe there are other chain, I don't know. You can investigate by yourself. So I would like to thank, first of all, HackerOne and the University of Milan. Without them, this would never be possible. I would like to thank my professor Marco Anisetti and the PhD Filippo Berto from University of Milan. I would like to thank my old university colleague Alberto Barbieri here and my friend Edoardo Vignati. And of course, thank you for your attention, for being here, and keep your cash safe.